Okay, just a little bit of bookwork here first of all. We've got a triangle, right angled triangle. You can use Pythag to get this formula here. Divide by r squared all the way through, so x squared over r squared can be rewritten as x over r squared, can't it? So you get this. Similarly, the y over r all squared equals 1. X over r adjacent over hypotenuse is cos, so this is cos squared, which we write like this. Y over r opposite over hypotenuse is sine, so that's sine squared. So you get cos squared plus sine squared is 1, or sine squared plus cos squared is 1. That would then lead to divide by cos squared, so you get 1 plus sine squared over cos squared. We can write that as sine theta over cos theta squared, can't we? Simple indices rules. And that's tan squared. So you've got tan squared, cos squared over cos squared is 1, divide by cos squared, sine squared over cos squared is sine over cos all squared, same thing, which is tan squared, equals 1 over cos squared, 1 over cos squared. You can write that as 1 over cosine theta squared, can't you? Same thing, because that's 1 squared over cos squared. And that will be sec squared, because sec is 1 over cos. So that's the formula, some of the formula that we can use when we look at problems. We're going to consider something like this, for example. See the form of this? Can you see when you square root both sides, cos will equal the square root of 1 minus sine squared, theta square rooted. And can you see that this, in terms of its form, is very similar to this, isn't it, here? See the square root? So why don't we just try it? So let's try x equals sine u. Okay, and then we'll have a 1 over square root 1 minus sine squared u, won't we? Or sine theta. Let's use the symbol theta then. Okay, because it looks easier on the eye. So the nice thing is when you do dx d theta, differentiate sine, you get cos. So the dx then is equal to cos theta d theta when you split that up, so to speak. So you can replace dx by cos theta d theta. So let's see what we get, because these, once you've started doing these types of integrals, you will become accustomed to making these sorts of substitutions. So we've got 1 over 1 minus x squared, square root of 1 minus x is sine squared theta. And then the dx, we can replace, this is dx here, which I omitted to write. We can replace the dx here by cos theta d theta. 1 minus sine squared is cos squared, and the square root of that is cos, so this is 1 over cos. So it's cos theta over cos theta, which is nice, because that's just 1. And the integral of 1 d theta is equal to theta plus k. And theta, that was our substitution, wasn't it? If we inverse sine, so that tells us what I is. So it's the inverse sine, both sides, you get theta plus k. So it's the inverse sine function is the integral. So anything like this, we try x equals sine theta.